Good evening, everyone. My name is Kevin Lagore. Welcome to another episode of Focus Astronomy's virtual star party, Star Stream. We do this every month, once a month, right here at the Focus Astronomy YouTube channel. It's a free virtual star party where we go explore the nighttime sky and broadcast live images off of our telescope. Tonight, our telescope is actually situated at Skies Away Remote Observatories, which is in Central California, near Bradley, California, or Paso Robles is probably the largest city nearby. They are an awesome location where you can actually install your telescope and they will host it for you for a monthly fee, giving you access to perfectly dark skies, on-site support, and has the capability to house telescopes up to about 24-inch in aperture. And that is where our telescope is situated tonight. I am also joined by my good friend Richard Wright, who I'm going to bring in right now. There's Richard hanging up in the corner. And I don't know why my little blurb isn't up there. So I will have to figure out why I'm not a floating head up there. But, I'll figure that out in a minute. But anyway, there's Richard. He's hanging up there. Let me see while we're doing that. I will figure myself out. There I am. Boop. There we go. So Richard is actually joining us from Florida. So, hey, Richard, how you doing?
Hey, Kevin. Great. A little later here than it is there, but I'm good.
Yeah, well, thanks for joining us. Last month we had Trevor from Astro Backyard. And for those of you who might not know Richard is like a world-class astrophotographer. He's worked for several major companies in the telescope industry. He's a writer for Sky and Telescope. He's done articles for them and just an all-around cool person. And he actually helped a lot with the software that's actually running the telescope this evening, and that's called SkyX from Software Bisque is the company that makes that. And that's what we're going to be running our telescope on. And just to let you know that the telescopes are actually real, here is our facility tonight. This is the Falling Eagle Observatory at Skies Away Remote. It houses two Skywatcher Esprit 150s. Our telescope tonight is the furthest away from the camera, the North Pier. That's a 6-inch Skywatcher Esprit 150 apo refractor. So it uses three lenses inside of its three pieces of glass in its objective lens, providing extremely sharp images. That has a full frame 61 megapixel monochrome camera, a ZWO 6200 on the back, with a FLI centerline filter wheel with 7 filters that will probably be bouncing through tonight. And all that's riding on a big, massive Software Bisque Paramount MX Plus. And Richard and I have pretty much that same setup at both of our houses as well, except not under nice dark skies like this particular one. Anything you want to elaborate on while we're on the equipment, Richard? Or
No, just this is I used to poo-poo remote setups. I'm like, I want to go out there like I'm the hunter. I want to set up and capture my prey. But I've started using this system, and it's a game changer for sure. You just get on about 10 o'clock, fire it up. Everything is set up. Everything's ready to go. The weather's good. And you're still running everything like it was in your backyard. It just stays set up all the time. So it's a very nice, it's a very nice way to image.
yes,
Yeah.
if you have the capability to either have a remote setup or you can even rent time on a remote system. There's a lot of other facilities that you can rent time on. It is kind of a cool way to acquire data or maybe get to use something that you wouldn't generally have access to, or even the conditions for that matter.
As
But
Ferris Bueller said, if you have the means, I highly recommend it.
it's so choice. So tonight, Richard and I are going to be your host as we bounce across the remaining winter skies. We have about a month left from the winter skies. So, like I said, I'm in Phoenix, Arizona. Richard's in Florida, and the telescope is in California. So that's we're all over the place right now. But all the images that you're going to see tonight are live. There is a chat going on the YouTube channel right there. So if you guys have any questions, Feel free to write them in the chat for Richard or myself. I can see it and I'll pass that along to Richard. And yeah, we should probably get started because we have a lot of targets to
Lots
go
of cool
through.
stuff up tonight. Yep.
And that is our webcam mutinying against us. Sometimes it bounces around. So the
Not
first
our live
object.
view.
There we go. Um, the first object tonight is, of course, the moon, which is one of Richard's favorite targets. So I'm really going to hand it off to Richard to start talking about the moon, and I'm going to be controlling the telescope. Let me see how we can do this because it's going to be really bright. So I guess I could put the H alpha in here.
Yeah, I'd switch to the HA on that. Yeah. So while Kevin is doing that, yeah, he's right. I love the moon. I know I'm probably better known for my deep sky astrophotography, but I'm a closet moon fan. Every time somebody's like, "Well, we can't do anything. The moon is up." I'm like, well, take pictures of the moon. The moon is awesome. It's not as dynamic as the sun, but it is pretty dynamic. It changes every night. In fact, it changes from hour to hour. There was an outreach I was helping with my own astronomy club. We were at a brewery, and I stayed on one crater all night long, and people kept coming back and looking at it. And the bowl of the crater was lit up, but the mountain in the middle of there was a central peak in the middle of the crater, and it was casting out this long shadow like a gnomon on a sundial. And over the course of even 20 or 30 minutes, you could see that that shadow was moving across the crater as the sun was moving, coming up over the limb of the moon. So it's pretty cool. The moon is also, it's our closest celestial neighbor, which makes it a lot more comprehensible than some of the, billions of light years away and hundreds of thousands of millions of years and all that sort of thing. It's only about 250,000 miles away, only 250,000. That's still a pretty long drive. Little long still. You're going to want to go like maybe half a second or less, I think. Actually, try like a tenth of a second if you haven't clicked it yet. Yeah, we'll figure it out. Um, so the moon is like right next door, so to speak, and it's not that big. It's actually, it's 6,786 miles around, or let's see, I got my notes. 2,800 miles across. The United States is 2,800 miles across. The moon is 2,160 miles across. So if you held the United States up across the moon would actually be smaller than the United States. But that's kind of cheating. That's like putting a flat map up against a sphere or a globe. If you laid the United States down on the moon and it actually wrapped around the surface, you'd see the entire United States from California to Virginia with about 500 miles to spare. Which means when you're looking at the moon, these sizes are fairly comparable to like the state of Texas or the county that you live in. When you're looking through a telescope, it's not. This thing is larger than the entire solar system, and it would burn your eye out if you looked at it. It's very close and personal. So I love observing the moon. Just last night, I resisted the temptation to put a camera on the telescope, and I just sat out back and was cycling through my eyepiece collection. And uh, Copernicus, which we may see here in a minute, was just amazing. The floor had a silhouette of a half moon shadow in it. The central peak was very prominent. There we go. What was that? A thousandth of a second. So here we're looking at the moon. North is to the left, and the bottom is down there on the right. And so down there at the bottom is the east, and then the west is up at the top. You see the terminator, or that shadowy area, is where the sun is rising right now on the moon. And if you were in a crater over there, you can sort of see some of the craters, or the rims of the crater are visible, but there's dark around it. The floor of the crater, it's like being in a valley and the sun is coming up. Until the sun clears the mountain, the valley is not going to be in sunlight. And you can see that on the moon on any given night. And it doesn't care about light pollution. If you live in the middle of downtown Manhattan, New York, or wherever on top of an apartment building, you can see these crater details with a pair of binoculars or a very small department store telescope, or a very fine small refractor from Skywatcher, of course. But you don't have to have a big mega observatory to get amazing views of the moon. So now we're a little. Did you go longer on that one?
A
Yeah.
little bit.
Yeah.
This system's really designed for deep sky, so the moon's kind of
Yeah,
an
yeah. I
afterthought.
actually I shoot. Yeah, when I shoot the moon, I'll put my DSLR on the back of the telescope. I like to take a full frame image for reference and say, here's what the whole moon looked like, and then I'll slide in a Teleview PowerMate and like a ZWO or some other kind of high speed video camera, and I'll shoot several thousand frames, and then I process it in auto stackered and programs like that. Lucky imaging is what we call it. So you're taking lots and lots of little bitty tiny short exposures, very unlike deep sky photography. In fact, to some degree it's a lot more fun than deep sky, because in a few minutes you can get a lot of data and then spend time processing it and zooming in and cleaning up to see all of the craters and the detail. But many times, if I'm shooting HA like Kevin's doing here on a deep sky object, if the moon is up, I'll just slew over to the moon and take a photo, and I like to overlay that and say, because people are, when they see this galaxy or nebula, they're like, wow, how it must be a million trillion zillion magnification. I'm like, no, actually, this is a really large object. And here it is in comparison to the moon. And you see that it's like a couple of moon widths across or something. And like that big thing is hanging over your head all the time at night, but you can't see it because it's so dim. That's, in fact, that's really what a telescope's job is. It's to gather light, not really to magnify. Let's see if we can find some features on the moon. I see Copernicus there. Yep, Kevin's mouse. He's got Copernicus there. I was looking at that last night, and Kepler is just popping out, which is up and to the right a little bit of Kepler in this image. How about Tycho, Kevin? Can you show him where Tycho is down at the bottom? Tycho is one of the more famous craters. When I used to do scouts and I would do telescopes, I called it the bullet hole in the moon. Through an eyepiece, it does look like somebody shot the moon with a bullet and it made a big O splot. Tycho is actually the youngest major crater on the moon. It's about 50 miles across. So that crater that you see there is not millions of light years away, and it's not millions of light years across. That's only 50 miles across from one side of the crater to the other. And it's only a little over 100 million years old, which means the dinosaurs probably saw the impact on the moon that created Tycho. And then Tycho also has this really prominent ray system, uh, which I think we just lost. Are all of these the same length? Oh, you went back to luminance.
Well, I was trying to see if there was a way to mess with the screen stretch
Ah,
or
yeah.
control
Okay.
image.
Next time it comes up, I'll show you a trick in this. Uh, we'll let it finish. I want to talk about the rays for a minute.
These are
Uh,
big 60 megapixel images of the
yeah,
rays.
yeah. The rays are basically when the crater hits. Okay, go up to image tools, Kevin. See the tab up
Oh yeah,
there
that's where it's
at the
at.
top? Yeah, yeah. So you can go to none, which works good on the moon, and that just removes all stretching, and that, for something that bright, um, works pretty good. In fact, you can see a lot of the rays radiating out from Tycho. The full moon is actually one of the best time to see the rays. These rays are lunar regolith that got blown up and just, like you would expect in a big explosion. And they're made of, they have a lot of aluminum in them and a lot of titanium in them. And even though it's a major feature on the moon that you can see, it's like it's very light dusting of snow. It's like they're not even an inch thick on the lunar surface. And they're very metal rich. I was watching for fun. I was watching Space 1999, which is a real cheesy sci-fi show from the early 70s. And they were on the moon and they had this emergency and they needed titanium and they couldn't find titanium ore and they were mining on the moon. And where's the titanium? Where's the titanium? And it's hilarious because literally it rains titanium whenever a meteor hits. Titanium and aluminum are all over the place. If if you think about it, from a resource standpoint, if we wanted to build a city on the moon, it would be really expensive to ship metal to the moon. And in fact, even if you were on the moon and you mined all this metal, it would be so expensive to bring it back, it wouldn't be worth it. But if you wanted to build something on the moon out of metal, it would be much cheaper to just dig up the metal on the moon. And of course, you're not just digging up humps of metal; you still have to refine it. But you could process that on the moon and build spaceships and habitats and cities and that sort of thing. And most of the plans, the long-term plans where we talk about going back to the moon, that's what we plan to do. We plan to use the resources on the moon. Even though it looks like a great big gray rock, there's all kinds of things up here that we can make use of, including water, to make buildings and habitats and cities and so forth and so on. But oh, we got a nice view. That's Tycho right there. Really nice view of Tycho. And if you watch the movie 2001: A Space Odyssey, there was a magnetic anomaly right there in that crater, and that's where the monolith was. And down a little bit, I don't know if you know the crater to the left of Tycho. There's a big round crater with like a one, two, three, four, five little craters. No, up. That's it right there. You see the little craters in the middle? That's Clavius, and that's where the lunar base in the movie 2001 was filmed. So as a kid, all I wanted to do is grow up and go to the moon. That's probably never going to happen, especially if my wife has anything to say about it. But I can go out in my backyard and I can go to the moon anytime it's even reasonably clear. That's another thing I love about the moon is if it's a little hazy, the weather does not have to be nearly as good for lunar observing or lunar photography as it does for deep sky objects. So every time somebody says, "Oh, I can't do nothing. The moon is up," it just makes my skin crawl because uh, it's like saying I can't take pictures because it's dark. It's like, no, we take pictures of things in the sky. Some of them are dark and some of them are bright. So I'm sure solar imagers feel the same way about I can't do anything during the day. Anyway, so uh, Kevin, what else we got to look at tonight that's a little more far out for everybody?
Yeah, so Richard's like a master of the moon. He also does really good deep sky stuff. But normally here, when we're doing these virtual star parties, um, we're generally. Oh, sorry, I had my mic turned down a little bit just
Yeah.
because I didn't want anything to be too loud. Anyway, hopefully you got there we go. That's better. Yeah, normally on these virtual star parties, we've never done the moon before. I've done it once, but the moon is its own world, obviously, and you could spend. So we have some friends that's all they do is that. Um, but moving out a tad bit further, the next one up on the list is the double cluster. The double cluster is a is actually two clusters of stars. They're in the constellation of Perseus. So we're gonna slew the telescope over there right now, and have it go find that while we're doing that. I am gonna see if so David, our friend David, who actually owns the telescope that was closest to the camera, he's running his telescope tonight, and he's kind of following along with us with the double cluster. So our telescope, the one that Richard and I use the most, and what we're using right now is a monochrome sensor. It's black and white as opposed to color. Now, black and white tends to be a little bit more sensitive. We can see more structure. It's usually what most professional telescopes will have on it. But some of the targets are really dynamic in color. So the unique thing tonight is David's system is going to chase alongside of us with ours, and we'll switch over to his and see the color, because this particular cluster has some interesting stars in it that are red, which means it's an older cluster. But I'm going to go ahead and get the imaging run going. Control imager. Live stack. this might be a good time, Richard, to talk to or tell people about why we, in layman's terms, why we use stacking for astrophotography and what's going on
Oh,
here
sure, sure.
with the telescope.
So, what a good opportunity. I'm going to plug my Sky and Telescope article. In the April issue, I wrote an article about understanding stacking. So, I'll refer you to that as well. But the reason we stack these images is because these objects are very faint, and you need a lot of light. If you take a photo with your camera at a birthday party, there's trillions and trillions of photons of light coming into that sensor in a very short amount of time. For these objects up in the sky, it's very, very dark and there's very, very little light. And the light shows up kind of randomly. And so you don't see a nice, clean, smooth image because the light is showing up. It's kind of like a light drizzle. You know, what you want, a birthday party or a wedding image is a pouring down rain, with the camera. But when you're looking up at the night sky with the camera, it's like a very, very light drizzle, pitter patter here, pitter patter there. And you don't get a nice deep exposure with lots of light on the sensor. So we expose it. We want to expose for as long as we can, but we can't leave the shutter open indefinitely. It's too hard to track accurately over long periods of time. Also, we because of the large dynamic range, which is the difference between light and dark, we can't expose that long without overflowing the camera. So instead, we take many many exposures and we stack them together. You can add them together, or you can average them as they accumulate. Mathematically, you get exactly the same, what we call the signal to noise ratio, which just basically means the longer you go, the smoother and smoother the image gets. The longer it rains, the more water collects and the smoother and wetter the driveway is. And so we want lots and lots of photons to get a nice deep exposure. And so we're battling, mount things. We're also battling sensor noise, which is competing with this what we call shot noise from the pitter patter of photons. So the more of these we take and stack together, the better and better the quality of the image becomes in terms of a noisy, grainy image. And you can see this. You don't even need astrophotos. If you just hold your phone up or your cell phone or camera up and you take a picture in a low light area, you're out in a dark alley. If you're able to focus, you'll notice the picture is very grainy and kind of dirty. And that's the same type of noise that we're trying to defeat. Only a back alley is still a lot brighter than something in the night sky is that we're trying to capture. Of course, a lot of cell phones actually do this stacking too. My iPhone, if I hold it still, it'll take several dozen very short exposures and it lines each image up and combines them to give me a nice crisp image. I believe they were doing that. I hate to do this to Apple, but I believe they were doing that on Android first. But Apple started doing it too with their cameras. And amateur astronomers, we've been doing that for years, of course. Take lots and lots of photos and align them and stack them on top of each other. This is one of my favorite visual objects too. I really don't like looking at galaxies and nebula through a telescope. My wife described it as snot on an eyepiece once, and I can't argue with her too much. The moon is amazing through the eyepiece. No camera does it justice. And there are many deep sky objects that also the camera doesn't really do justice. And this is one of them. A nice uh, star cluster or globular cluster or open cluster like this one here, just the sparkle that you get. It's a really great show pleaser at outreach things. And I see, Kevin, have you ever seen the alien in the top cluster here? There's a little,
I have not.
there's
Is
a
it this
little,
little doodad in here?
yeah. If you zoom in on it in an eyepiece, I think you can see it here. I can just kind of make out the outline here. In the eyepiece, I've only found one reference to this, and they called it the cowboy cluster deep
Oh
inside.
yeah, because
But
there's his
there's
legs.
yeah, there's a head, and there's actually like three or four legs when you're looking at it in the eyepiece, and it looks like an octopus sort of little alien guy there. Um, But I love showing that to kids, and say you just ask people what they see. It's kind of like a Rorschach test. You can anyway that little alien, not very well known because I couldn't find many references to it.
I
Somebody at the Star Party showed it
never.
to
I've
me.
been looking at this thing for years, showing
Uh,
people, and never knew that. So now
yeah,
I'm gonna show them.
now you got to show them the little alien because you say, "Hey, would you like to see an alien?" Yeah, that gets people's attention.
Yeah. So the double cluster, which we're seeing here, obviously gets its name because it's two open clusters of stars.
Hmm.
The upper one is NGC, or New General Catalog. Most deep sky objects are cataloged in catalogs. Um, the most well-known one, of course, is the Messier catalog, which we'll be diving into a bunch of the popular ones tonight. NGC would be kind of the next deepest catalog, I would say, and pretty much every Messier object has an NGC number as well. So you could think of the Messier catalog was around, and then they kept finding stuff, so they kind of made a master catalog, and then they kept finding more stuff, so then they made the index catalog, which is IC, and then there's all these other weird exotic catalogs, and we're going to dig into some of those tonight. So NGC 869 is the top cluster where Richard's cowboy is, and the bottom cluster in the frame is NGC 884. These are 7,500 light years away. They're actually out in the Perseus arm of the Milky Way, so the clusters are older. And this is where I want to actually, David's watching. David's running our second telescope, which is actually his. He's nice enough to share it. So here's David's setup. David has a color camera on here. I'm going to go ahead and stretch it. And let me see if I can make this a little bit bigger. There we go. But you can see some of those stars in there, like this one and this one. There's a lot of orange stars in this cluster because it's an older cluster. Most open clusters are generally older. And you can generally tell by the amount of red stars that are inside of there. And these clusters are actually naked eye visible from an average, just getting out of the city a little bit. You can actually see this glow up in the constellation of Perseus, not far from Cassiopeia. And because of that, the Greek astronomer Hipparchus actually is the one noted for actually documenting it first in 130 BC. But it wasn't until the 19th century that William Herschel came along and actually dubbed it a cluster, and that's where it finally got its name. But it's a very easy object to see. If you ever go camping or you're just going to go out, get away from the city a little bit, you can get a nice view of this in binoculars or even a small telescope. I'm sure you've looked at it through like your little 70 millimeter refractor. So
yeah, each one of those is about the size of the moon that we were looking at a minute ago. So they're, a wide binoculars or a wide field through a telescope is really great. If you got one of those Schmidt-Cassegrains and you're really zooming in on stuff, you're only going to see, part of one of these. So don't overdo it. But
it looks a lot like spilt glitter, especially in a really dark sky with a wide field. When you look at them from like your backyard, you can tell there's two clusters there. But when you get to a dark sky site, there's so many stars in this region that they're just everywhere. So that's the double cluster. We're getting pretty much to the end of the season for it. But it's a popular one to go check out. But I know we have a lot on the list, so I think we should move to the next target, which we're going to start playing with filters here in a minute, which will be kind of neat. And we'll talk about why we use different filters on these telescopes and another advantage of using a black and white camera. But the next one, we were talking about the Messier catalog, so we're going to start with none other than M1, Messier 1, the Crab Nebula. Alex, David is running the exact same telescope. We're running two Skywatcher Esprit 150s, and they both have ZWO 6200 full frame cameras on them, except ours has a monochrome black and white camera and David's has a color. So, which actually comes in handy at times to run them both. So, okay.
And this is much smaller than the moon is.
Yes.
It's going to be dwarfed in the full frame.
We have all those megapixels. So.
Yep.
I did this last month with Trevor, and it was actually really impressive, especially when we switch filters. But M1 is a supernova remnant in the constellation of Taurus, the Bull, 6,500 light years away and about 6 light years in diameter, and it's expanding. It was originally observed by Chinese astronomers in 1054. It was visible for nearly a month during the daytime. They called it the guest star. But it'd be really neat to see one. We almost thought we were going to lose Betelgeuse like a year ago, the big bright orange star in Orion, but because it was dimming, and now it's back. So, oh well, we'll just wait for it to explode one day.
And there it is, that little smudge.
Highly technical term in the field of astronomy. Smudge. Faint, fuzzy, puffball.
Yep. We'll introduce dust bunnies, in the advanced graduate version.
So M1 obviously was first recorded in 1054 by Chinese astronomers, but it was later discovered by John Bevis, and later observed by Charles Messier because he mistook it for Halley's Comet. And this is really what started the Messier catalog. Was Charles Messier was actually a comet hunter, and as he was perusing the nighttime sky looking for comets, he kept running into all this other stuff. And M1 was the first one of those things. So he jotted them down and made the Messier catalog so he wouldn't run into them again. And now we like to hunt down those cool little things over and over and over and take pictures of them and stuff like that. So M1 was the first of the Messier catalog and is what created it now. Yeah. But it's also known as the Crab Nebula, which was coined by astronomer William Parsons, who observed and sketched the nebula with his 36-inch telescope in 1842 and said it resembled a crab. I've looked at it a lot, and I've never quite figured that. But hey.
They often describe Messier's catalog as, this is to help people not misidentify comets. And so his catalog were things that looked like comets. But there's something this does. Sure, I might mistake this for a comet with a small telescope in the middle of Paris. But, many of the objects at some point he had to go, nobody's going to mistake this for a comet, but we're going to add it anyway. Because there's some really great open clusters and globular clusters in that catalog. One of them is even just a star, or I think it may be a binary star.
M40.
Nobody's mistaking that. You gotta be eating some weird mushrooms or something to think that this might be a comet. It's just like, well, I'm making a list. I might as well make a list of interesting things since I know about it. And the catalog was actually extended slightly after his death. He had a partner towards the end that was recording them. So there were a few at the very end that he didn't add.
Yeah. Yep. Yeah, this one's an easy one to get. It's a little bit more challenging than I think people think. You can see it from in town with like a moderate telescope, like a 6-inch, 10-inch telescope, but I will say it's not the most exciting object to see. You need some serious aperture to be able to see the little tendrils that are like this cage that sits around it. So what we're looking at right now is the Crab Nebula in visible light. So all the light that's coming through the filter onto the camera is what our eye pretty much sees. But monochrome cameras or black and white cameras, we have the ability to isolate certain wavelengths of light. And this is where color cameras fall short on. You can use them, but it just doesn't work the same. So we're going to play with the filters. So hydrogen is the most abundant element in the universe, and obviously because of that, it's all over the place, but it emits light in different frequencies, and one of the most abundant frequencies is called hydrogen alpha, which is deep red light. And there's certain objects and details that we're able to see using that filter that are very unique, and we're able to isolate and study certain phenomenon by using what are called narrowband filters, which we're using right now. These are filters that isolate very specific wavelengths of light. So we just move the hydrogen filter into the light path, and it's going to block everything else out, including that moonlight. You can see up here in our little sample how it's all like gradient, dark on the left and bright on the right. That's moonlight. But the hydrogen alpha filter is going to knock all that out. Watch M1 in the middle of it. You'll be able to see the change in the light, and you'll be able to see this cage-like structure that actually sits around the nebula. It's very... it'll become more and more apparent as the images stack, but it gets very impressive with this combo.
You know, Kevin, people ask all the time, well, how do we know what things are made of? How do you know that's made of hydrogen? And that's where, you know, the study of light is really the beginning of astronomy. We know there's this one wavelength, this one frequency of light, of energy that comes down in light. And the only thing that makes that exact frequency is hydrogen atoms when a particular electron moves from one orbit to another. So it gets energized, and then when it cools off, it drops down and emits a photon of light. And that's like a fingerprint. It's like a DNA of this atom in outer space. Well, this is literally a telescope with a filter on it. It's literally an atomic hydrogen detector, and you're detecting atomic hydrogen. That's the only thing that's showing up in here. What about all these stars? Well, the stars got lots of hydrogen in them too, and so they're also emitting, you know, hydrogen alpha light at that particular wavelength or that exact fingerprint. And that filter is not letting anything through except for that one little wavelength of light coming through. And you can already see more of the structure now, Kevin. So I'll let you.
Yeah, it does a pretty good job, and I'm gonna really stretch it just so we don't have to sit here forever. But yeah, that's what's kind of nice about using these monochrome cameras. You can do narrowband. Someone in the chat was mentioning that Tony Hallis has come up with a process to use narrowband filters with color cameras. You can use narrowband with color cameras. It's just, I wouldn't say it's a waste, but it's a lot more work. So
I'm not sure he came up with that. They've been doing that for a long time. He just the red pixels will respond to hydrogen alpha, and the blue and green will respond to O3.
And then there's multi-band narrowband filters nowadays, which let you kind of do it all in one rather than piecing it.
He's doing some amazing work, but I don't think he invented that.
Let's see. So on M1's pretty interesting because there's actually a pulsar at the middle of it. And these are neutron stars. They're leftover corpses of an original star that died. This is what's left of the original star that's supernovaed. And it's only 19 miles wide. It's about 30 kilometers. If you're not here in the U.S. and using metric, which we should. But these spin 32.2 times per second, and they emit a lot of radiation, but they're very, very exact. So M1 is studied a lot because it has that pulsar in the middle of it. And that supernova that originally caused this whole thing is causing that outward shell, that cage-like structure is expanding about 900 miles per second, which is about 1,500 kilometers per second. That's a very cool object to see in the night sky.
Yeah. And we have, people have made animations. This is actually, you can see change in this over the last two or three decades as it's moving outward into space. So this is not a static object either that never changes. It's which is just phenomenal to me that we can, you know, we live long enough at this, or at least this is close enough to us that we can detect the outward motion of it, you know, over the course of our lifetimes. So
yeah, it's cool. A very, very cool object to see there. So so that kind of wraps up M1. That's the cage-like structure. If you actually want to observe that cage, you know, real gnarly looking structure there, you need a very large telescope. I've seen it once visually. This bright area. I think we used an H beta filter, and it was on a 28-inch telescope. So and was also on top of Kit Peak, where we saw Uranus naked eye. So
What's
very dark.
What's an H beta filter? I know, but I think you should explain it.
So there's different types of hydrogen filters that can be used in astronomy by isolating when hydrogen gets excited, like Richard was talking about, and the atoms change. It can emit light in different colors depending on the level of excitement that the atom goes through. H alpha being the most powerful and easiest to see. Then there's H beta, but they're different colors on the spectrum. So H alpha is way in the red part of the spectrum, which the cameras are very sensitive to, but our eye is not. However, H beta is in the blue greeny part of the spectrum, which is actually where the human eye is much more sensitive to. So you can use filters like that visually to see that detail. Photographically, if you used an H beta filter versus an H alpha filter, it's showing you the same stuff, but you're more prone to light pollution and moon glow because of the frequency of light that H beta sits in, that bluish column of light. So H alpha is ideal to use because there's not as much light pollution. It completely blocks out most of the moonlight as well. There's not as much issue over in the red part of the spectrum as opposed to the blue part of the spectrum. So H beta is more of a visual filter. H alpha is more of a imaging filter.
And it doesn't look blue or red. There's not enough light to excite the part of your eye that detects color. So even though you have those filters, it improves the contrast, so you can see it better. But it still looks gray to look at. There's another object on our list we may get to a little bit later that's really, really bright in oxygen 3. And we'll talk about that when we get to it.
So I like going after faint, weird, stupid, off the beaten path thing. That's kind of one of the reasons why we do the Starstream virtual star parties, is to kind of encourage people to, whether you're learning about something different or just seeing something different. The telescope that we have out there and the conditions that the telescope sits under are ideal, and most of us can't get out there. And while this is a 6-inch telescope, the fact that the seeing conditions out there are so stable, and it's relatively dark. I mean, we have a big bright moon tonight, but because it's relatively dark out there and it's a really nicely set up telescope, we're able to see things much fainter than we would be able to with the same telescope in our eye. So a lot of the stuff we're going to be able to catch tonight through the telescope greatly surpasses what you would see even in some of the largest amateur telescopes out there. So that being said, we're on probably one of our most strange targets, and that is ARP 273, the Rose, which is appropriate because Valentine's Day is on Monday, if you needed a reminder for that. There's some other cool objects up there, but this is very, very small, and I will blow it up here in a minute because I think the information I have on my notes for distance is completely off. Yes, this is 358 million light years away from the solar system, so way out there. I think it's actually probably the furthest target we'll get to tonight. So let me zoom in here. So there is the Rose. You can see kind of the flower portion up there, and there's the stem. Richard and I have notes up right there. It has the Hubble image of it, and it's actually amazing how much we're actually able to see in this telescope as opposed to the Hubble shot. Obviously, the Hubble shot is a lot better, but you can see the details in there are still pretty impressive. But this is in the constellation of Andromeda. It's kind of it's at the end of its season, so it's not in an ideal position of the sky, so it's a little bit low. But we're looking 358 million light years away, and this is an ARP galaxy. And the ARP catalog is really generally composed of like interacting galaxies. So this is composed of two galaxies that are interacting with each other. The top one, which is UGC 1810. If you start hearing weird like combos like that, like PGC or UGC, something that you probably, when you crack open a book or a star map and it's like, I don't see that catalog, it usually means it's really freaking faint, is what that usually means.
And the ARP catalog is really awesome. It's like the Island of Misfit Toys for galaxies. It's like, where does this go? It's just, this is a weird shaped, odd thing. And as Kevin said, most of the time it's because two galaxies got too close and they started interacting with each other, and they get literally bent out of shape, so to speak.
Yeah, there's a whole book, a really nice book that you can actually get. It's like a coffee table book, but it's all about the ARP galaxies. It's actually a nice one to go after, especially if you have like access to a big scope. Maybe your club has a big Dob, or you have an observatory that you have the luxury of using, a decent sized telescope. They're fun to go after because they are small. So the top galaxy that's basically the rose portion of the flower portion, that's UGC 1810. Where the lower, smaller galaxy is UGC 1813. The circular spiral arms of 1810, the flower portion, show the interaction between the two galaxies. And it's believed that the lower galaxy, the stem, which is 1813, passed through the larger galaxy and disturbed all of that. And our galaxy is going to do the same thing with the Andromeda galaxy, our next door neighbor, in about 4.5 billion years from now. So be prepared. Don't look up. So, but UGC 1810, the flower galaxy, is 5 times larger than its smaller companion. And the disk is still being distorted by gravity from the stem galaxy, or 1813. So, and there's a lot of star forming actually going on in the stem portion of the object here, but very cool galaxy. I have yet to try it out. I'm going to have to do it when I get out to dark skies again. But it's like magnitude, it's faint. You need a serious telescope to be able to go after this visually, and it looks like it's 15.2. So that is about the limit of a 16-inch telescope in a dark sky. So you need big glass to go after something like this. So.
If only somebody had a really big Dob.
Yes. Yeah. Real quick, since this is Focus's webcast, for the last 5 years, Focus Astronomy has been working on a what we call the Large Aperture Outreach Telescope. It's a large aperture Dobsonian telescope specifically designed from the ground up to be one of the largest instruments for public use, for mobile use here in Arizona, because that's where we're based. So it was made possible by donations and crowdfunding, Richard being one of those. So thanks to Richard for helping out with that, among a bunch of other people. But it is a 28-inch Dobsonian telescope, and next Sunday, after 5 years of work, it will finally be finished and assembled, and waiting for the world to return to somewhat normal state to start showing people the universe with a massive telescope. So that's kind of exciting. But hopefully this will be one of the objects when we get to a dark location, and we'll try to check that out, because that's exactly what you need to hunt down little tiny things like that. So, yeah. But anyway, that is ARP 273, the Rose.
And look at that, 5 minutes. Imagine if you spent an hour or 2 or 3 on that, Kevin. There's quite a bit.
When the moon goes away, it'll be a good one to try.
Yeah, there's a lot there.
But yeah, go try it. Even if you have a little imaging setup, it's, a lot of the cameras nowadays are very high resolution, so you can still get some good stuff. I mean, this is a 6-inch telescope. We're pushing the limit resolution-wise with this thing, and it's there. You can see it. So it's pretty neat. There's also probably a ton of other galaxies in the background there as you shoot longer and longer, but there's the full frame. You can see just how tiny this thing is. So
the falling Eagle Deep Field.
There you
It's
go.
true. A lot of deep sky objects that it's amazing. You start poking around and you're like, if you zoom in, there's so many images that I wish I could post online, but you can't appreciate them unless you just zoom in and kind of swim around in that sea of stars. You know, there's a galaxy, there's a galaxy, there's a cute little galaxy, um, and uh, they show up and all over the place.
Well, now it's, I mean,
There's no galaxies that where you're going now, though.
no,
They're
but
all
it
blotted out.
also it doesn't need much of an introduction because it's the most photograph one of the most photographed things in the nighttime sky. You practically know what season it is um, when everybody starts posting pictures of it. But that's the Orion Nebula. I don't know about you, Richard, but it's a target that I probably shoot every year.
Yep,
Um,
yep. You have to. There's a it's like a moral obligation to shoot that and the Horsehead are the
yeah.
two things I just have to shoot a little bit every year. I don't always post them because everybody's posting M42. It's like, yep, that looks great. But it is, one of the most impressive. It also I was talking about nebula looking like snot on the eyepiece. M42 is an exception. M42 is amazing with any telescope and any eyepiece, unless there's a street light right over the top of you. And it actually looks a lot different than the photos do. It looks like a big eagle or something. And it never ever fails to please, either through the eyepiece or with the camera. That's the moon.
Why
That's
did
not.
it kick me out? Oh, there it
Oh,
goes.
oh, it's still going.
Oh, I had a filter change. That's why. We're
Ah,
gonna play
okay.
with filters on the Orion Nebula too because it's very there's a lot of signal in there, so we're gonna show the different types of filters
Oh,
there.
you're doing 30 seconds on luminance. Yeah,
Yeah.
it's gonna be all blown out in the middle.
Boop.
Here it comes.
And M42 or the Orion Nebula is the easiest nebula to shoot. You can go out with a why is it rebelling?
It's easy to find too. It's basically the sword in Orion's belt. Um, and naked eye, it's like a big fuzzy patch. Even you don't even have to be under like Boreal Zero skies to see that fuzzy patch. It's pretty
Yeah,
prominent.
you can go out and the moon's real bright right now. If you had a small telescope in your backyard, you could
Mm-hmm.
go out right now and point it there, and you would see.
Yeah.
Obviously, it wouldn't show what the camera here is going to show, but you can start to see the nebulosity there. So it's very impressive in almost any size optic. Is the camera there? It is,
There we go.
along with some satellites.
Ah.
I'm sure we'll probably bring David's telescope in on this one too, if he's hanging out. Yeah, he's hanging out
Yep.
on Orion right now. But David's telescope is pretty cool because it's got the color involved. So I'll let him start stacking that up. But Orion is very dynamic with it. Actually, it's broken up into a couple things. So M42, or the Orion Nebula, is this section right here. M43 is this section, and then you have 1977, the Running Man, over here. So there's a bunch of different nebulas, and this whole region, pretty much the entire lower portion of the constellation of Orion, is in a very, very large molecular cloud called the Orion Molecular Cloud, or OMC1. So this region, M42, 43, and the Running Man, are really just dense portions of a much larger region. And the Horsehead, which we'll probably do here next, is another part of that. They practically connect to one
Yeah.
another if you had a
Yeah.
wide enough field and sat there and saw the dust. Um,
Much dust. Zoom in on in the middle there uh, by the bright where the trapezium would be. I'll tell you a silly story. So too much. So do you see how there's like a little dark area that extends into the bright area? Yeah, that right there. So I always tell people, they're like, oh, I don't have this, or I'm like, listen, we all start in the same place. We all start in the same place. I'm gonna tell you a true story. I bought a used 4-inch reflector at a camera store, and this was like many decades ago. But I remember in the backyard, poking around, looking around in Orion. and I came across M42, and I didn't know what it was, and I thought that was the Horsehead Nebula. And I remember I was so excited. I came in and I even told my wife, I said, I saw the Horsehead Nebula. You can't see the Horsehead Nebula with a 4.5 inch reflector, but you can see that. And that little dust finger sticking out there and the light glowing behind it. No, it's not the Horsehead, but visually, with a, really cheap, it was in really bad shape too, really cheap used telescope that I bought for $50. It was the most amazing thing I'd ever seen to a telescope in my life up until that point in time. And
Yeah, here's David's telescope with the color camera. So,
not the Horsehead. Oh, that color image looked nice.
and then the trapezium, you can see the stars. The trapezium, this little box of stars here in the middle, that is what's really responsible for illuminating that big cloud of hydrogen and multi other types of gas there. But it's very easy to get the color. You take like a Canon or a Nikon camera and you put it on a lens and a little tracking mount, and you can get color in it. So it's very impressive to see there. So David's telescope does a very nice job at showcasing that coloration there. Let me see if I can get this to play nice, because now it's like, oh, wait.
Do you have two color versions up at the same time?
There we go.
Oh, okay.
But so the Orion Nebula has been known for hundreds and hundreds of years. I think it even mentions it. It goes back into the Mayans. Ptolemy and Tycho mention observing Orion. Even Galileo has observations of stars within the constellation. But it wasn't until about 1610 by a French astronomer that they finally saw something. But he didn't really publish the findings. So a year later was the first documented observation of Orion in 1611 of the nebula. But it wasn't until Christian Huygens sketched the nebula, and I believe that's 1656 as when the first sketch of the nebula came out. And then it wasn't until 1716 when Messier finally was able to catalog M42 and 43 there. And then the first image of Orion, so like what we're doing right now, but the first picture of Orion wasn't actually done until 1880. So big history there. But it's an emission nebula, which means it's emitting its own light through stars lighting it up. It contains about 700 stars, but it's a star-forming nursery. But it's very, very active in multiple wavelengths of light. And this is where I like to get crafty with the filters, where we can kind of go back. So the first one we're going to do is we're going to switch into hydrogen. And this field is very abundant in hydrogen because it's all part of that OMC1 nebula, that big nebula portion of Orion. So all of this area that looks black is filled with nebulosity and dust and all kinds of cool things. And certain filters can help bring that out, as well as a lot of exposure time, just sitting there with the camera following and tracking that. So
space is dirty.
Yes, dust is everywhere.
Space is very dirty.
But this is a great object to start, your endeavors of astrophotography. Everyone has to do it. It's like an old friend. You see him every year. So there's hydrogen. The hydrogen alpha filter there, so you can see how dynamic it is. It's very abundant, and there's a lot more in there, but you need to do longer exposures. But let's see if we can get down the trapezium. It's kind of hard to see, but you can see some of the stars that are kind of hanging out inside of there. This is very impressive when you take a very long image in hydrogen because of how much stuff is out there, but 30-second shots, it's a slow process.
How many stars have you seen in the trapezium, Kevin? Have you ever seen more than 4?
6.
6? Yeah.
Yeah. A, B, C, D.
With a big scope.
And F.
Oh, yeah.
Yeah. But then there's H, I, and I think I is a double star. And then there's a map somewhere. I have to go check that out. So, but it's there's a lot of stuff in there, but they get really faint really quick.
Mm-hmm.
But I'm gonna go ahead and switch the
What's
filters
going
just
on there?
because we're not,
Now
so we don't sit on it.
you can see that fake horse head here, that little finger sticking out into the bright. The big arch, sort of, it looks like a big shell. Through an eyepiece, you see that. You see this big. It looks like eagle's wings, uh, outstretched. Never get tired of that nebula visually.
No, it's a fantastic. And the bigger the telescope and the darker the skies, the more impressive it gets. A big enough telescope, you can actually start to see shades of color in it, which is nuts.
Yeah, it starts turning greenish first. Green.
Here comes oxygen. This is the oxygen filter.
Okay.
So watch the switch. There's the oxygen filter. So different
Oxygen
detail there.
free. So remember, this fingerprint, the only thing that makes this light is oxygen atoms cooling off, and an electron moving from from a higher orbit into a lower orbit, and that energy loss pops out a photon of light of a very specific wavelength, and we can detect that from Earth. And this is how we know most things about astronomy, is by studying the light. In a sense, I guess we're kind of doing spectroscopy here.
A little bit.
We're using the light from these objects to learn about them, what they're made of, what their temperature is, how fast they're moving in space. It's really quite amazing.
So that's O3. This is double ionized oxygen is what we're basically watching. We did hydrogen, and then the last one is sulfur, which there's not a lot of sulfur up there. And the reason why we use these filters is because that's what they put in Hubble. So a lot of people like to use those filters. But sulfur, or S2, is probably the least abundant of the three filters. Orion has a lot of it in it. So the signal that we get through this filter is noticeable. But if you're getting into astrophotography, I'd probably say a sulfur filter is the last filter you should consider.
Absolutely. There's a lot of nebula that are basically invisible in sulfur. There's almost nothing at all coming off of it.
So it's a kind of an intriguing view. Yeah. It's really good for the trapezium to really get inside there, but it's very close. It's near IR. I mean, look at all the stars that are sitting inside of there, but it's almost a near IR. I don't know why. We just got this one fixed. That's why we haven't used this one too much yet, but we're basically looking into the dust now. So.
Yeah, the infrared light, it kind of goes through dust, so you can actually see through dust clouds at wavelengths that are near the infrared. So you can look at something that visually would be just a big black splotch, and we use infrared. It's full of stars. In fact, remember at the Texas Star Party that year, Kevin, it was completely cloudy, and we had an IR filter on a camera lens set up, and not on a camera lens, but on the telescope, and we were taking photos, and you could see the stars through the clouds with the infrared filter. It's pretty.
Yep.
Pretty cool.
Everyone else was getting drunk, and we were still shooting.
We were doing T-point runs on the Paramount under the clouds with an infrared.
There's your cloud filter, IR.
That's how to do it. There you go. Infrared is the cloud filter.
But yeah, the sulfur filter. I think this is the first time we've had the sulfur filter in. The filter wheel that's on the back of this telescope is very complicated. It's got two wheels that stack on each other, so getting the combos right has been kind of a bear. But Brian, who actually runs the Skies Away Observatory, spent one of the nights this week finally getting the time to do it. And thanks, Brian, for all the work you do out there on making this thing run. So, but yeah, that is the sulfur filter. Kind of an impressive, very cool look at Orion right there. But so that is M42, the Orion Nebula, 1,600 light years away. One of the easiest nebulas, most photographed nebulas in the nighttime sky. Go out, check it out. There's the luminance version of it. So pretty neat to see.
See the streaks? Is it too late?
I think Okay. I don't know why it keeps defaulting back to the moon, though. So
interesting. Yeah. It's hard to take a photo of Orion without catching satellites. There's a lot of geosynchronous satellites that fly through through that frame. Long before Starlink, we were picking up satellites on our deep sky, and which is long before Starlink. And Orion is infamous for it. Dozens and dozens of them.
As much as everyone hates Starlink, um, this broadcast is actually happened through Starlink. The observatory is actually remotely connected to the internet through Starlink. So imaging the stars by the stars is how I put it.
Hate mail now, Kevin.
I know.
Yeah.
How could you? When a telescope is way out in the middle of nowhere and there's no line, there's only so many ways to do it. So.
Yeah. Dark skies and civilization are not found together.
Yeah, they don't mix well. So. Yep. So this next target is the Horsehead Nebula, IC 434 B33, and the Flame. It's actually sitting behind Richard's head. There's the Horsehead in hydrogen.
It is my very favorite object, I think. Deep sky object to shoot. Very favoritist.
So I've started it with hydrogen. I find it works best with hydrogen, the H alpha filter, to get this one to come out. But this is also 1,600 light years away, and it's actually part of that big Orion OMC complex, the Orion Molecular Cloud Complex. It's right next door to Orion. But what's interesting about the Horsehead Nebula as opposed to the Orion Nebula is the Orion Nebula is an absolute walk in the park to see. The Horsehead, on the other hand, is a major challenge to actually visually see it. Mm-hmm. So I've seen it in something as small as I've seen it in a 6-inch refractor.
With an H
but it was with an H beta, yeah.
Yeah, H beta. Yeah.
Very dark skies. It was a TOA 150 Takahashi. But it was a very good sky, obviously, to be able to see it. So, but it is a challenge to see it. So
it'll show up well with your new Dob with the H beta filter.
Oh yeah, no problem. So
every year at the Winter Star Party, somebody's got a gigantic Dob, and with the H beta filter, you can definitely see it. Wow, this looks like my very first photo of it. It's this dark blob, but it's in there. It's in there.
And it's very easy to find. This bright star right here is Alnitak, the low star in the belt of Orion. I think it's actually the easternmost star of the belt. It's down by the sword. It's as the belt angles, it's the lowest one of the 3 stars.
Here in the northern hemisphere, it's the leftmost star in the belt. Yeah.
So that was if you want to go look for it, especially under a new moon, dark sky, the Flame Nebula is the easiest part to see. Generally, you can catch the Flame without a lot of work from a dark sky site. But the Horsehead is a lot harder to do. Generally needs a fair amount of aperture, probably at least a 10-inch. I didn't really see it until I got my 16-inch scope and an H beta filter. An H beta filter is really the trick. You can use a UHC, an ultra high contrast filter, because it does pass the H beta line, but it's not as selective as the actual H beta filter. So your contrast isn't as beneficial as, say, like an H beta filter. But what's cool about this nebula is it was actually discovered by a woman in 1888. Scottish astronomer by the name of Wilhelmina Fleming saw it on a photographic plate from the Harvard College Observatory. So it's kind of an interesting thing there. But another thing about this region that I think it's overlooked quite a bit is everyone's like, oh, it's the Horsehead. Oh, it's the Horsehead. It's yes and no. So the Flame Nebula is right here. And the Flame Nebula is NGC 2024. There's also a little nebula down here, which does not show up well in hydrogen because it's kind of a reflection nebula. That's NGC 2023. And then IC 434 is this nebula portion right here, where it kind of extends out. That's all hydrogen. That's actually what you're looking for when you're observing this region. And the Horsehead, was known as B33 or Barnard 33, which is a catalog of dark nebulas. A very cool catalog done by E. Barnard in the early 1900s on glass plates. But when you're looking for the Horsehead Nebula in a telescope, you're basically looking for IC 434, this background nebulosity. And then what you're looking for as far as the Horsehead is the absence of light there. It kind of looks like a black thumbprint on black paper. So you got to be careful with it when you're observing. I usually find moving the telescope side to side is the best way to actually see it, because you want to see what moves with the field there. But it's a challenging target. I'm not sure how much time you spent trying to observe that, Richard, being that you're an imager.
Not with a 6-inch. No, I've never seen anything smaller than like a 20 some odd inch dot. And I think some of those times we had a light, one of those light amplification eyepieces from.
Oh yeah, a night vision eyepiece will take care of that real
Mike
quick.
Buckland carries one around, or Al Nagler.
Yeah,
playing with one at the last winter star party, which was the last star party, before the pandemic 2 years ago.
But yeah, that's the Horsehead. The Horsehead is very challenging visually, but it's very easy photographically.
Oh yeah, it's really showing up there. If you zoom in on it, you can tell that it's actually like a finger of smoke that came up and curled over. It's not really smoke. Don't send in letters. We know it's not really smoke, but it's this dust. It looks like a big smoke coming up out of a chimney and then just kind of curling over on itself. And it looks, it's the shape of a chess horse, upside down, of course, right now. If you didn't catch on to that, so just put your laptop upside down if you have to.
Take that big monitor and go
see the little horse head there. It's just a smudge of dirt in front of all this glowing hydrogen. That's really what it is. No, don't. In the morning, Horsehead Nebula just disappears overnight. Astronomers stumped.
But if you have a modern camera and a telescope and you're just getting into astrophotography, if you've got one of those, narrowband filters, it's not a difficult target to do even from backyard.
Even without narrowband, a 60 millimeter telescope with a DSLR will pick this up very quickly. It won't be as beautiful as this with one shot, but you can pick it up with the camera very, very readily.
Yeah, cameras are much more sensitive than the human eye is. It's you can see a tiny telescope, a camera lens. You can get the Orion Nebula and the Horsehead in the same frame, without really any work at all. But visually, it's a completely different story. So good luck if you're trying to see it visually. It is a fun challenge. It's kind of a badge of honor that you do get to see it, because it's one of those objects that it's posted over books and charts and it's all over the internet. So a lot of people really go out of their way to try and see it. But as abundant as it is everywhere, it is a very difficult object to actually observe with the eye. So
you got to be somewhere really dark, and you need a lot of glass to get enough light to see it. And a H beta filter definitely helps.
Highly recommend it. Okay. The next one, I'm gonna keep the H alpha filter in there because it also works really well. But you've done some really good work on this one, Richard. So I don't know if you want to take it away on this target and talk about it a little bit.
Oh, the Christmas tree cluster. Yeah. So this is pretty cool object because it's actually kind of a Christmas tree twice over. Visually through a telescope, you don't see any of this nebulosity. You just see an open star cluster. And the open star cluster is shaped like a Christmas tree. So it's sort of triangle shaped, and stars go all the way down the edges of the triangle. And at the trunk, even, you can see it kind of squeezed in where the stump of the tree is. But with a camera, and it picks up the nebulosity, there's also a cone nebula, which, Christmas tree is a cone, sort of. But it's upside down oriented relative to to the tree. And there's all kinds of it's actually a challenging target to process well because it's got a lot of red from the hydrogen, but it also has a lot of reflectivity in it. So there's some blue mixed in with that hydrogen, and trying to color balance that out is tricky. I've shot it with one shot color and I've shot it with filters. So we were doing the narrow band with the filters, but you can also use red, green, and blue filters. The red will capture just the red, the blue will capture just the blue, and the green, and then you combine that to make a full color image, and you get a little bit better. Uh, you get a little bit better. It's more, you get more signals, so it's a better signal to noise ratio. I find it works much better with RGB filters, and I'll shoot a little bit of HA hydrogen to mix with it. The hydrogen being red, so it mixes in there and really helps punch it up a bit. But through it's a great outreach target for in the city because it's an open cluster, and most open clusters are very readily accessible, and most people can see these shapes in these clusters, and the Christmas tree really does look like a Christmas tree. Let's see. I don't know if we could. Can we see it in this image? Doo-doo. Problem is, you get so many other stars. Yeah, you can. Yeah, I see it. Um, well, I can't point with the mouse. I also see the cone. The cone is like right upside down, and the tip of the
Cone's
cone,
right here, and then the
the,
tree kind
the
of comes out this
the
way.
the cone, the tip of the cone sort of touches the tip of the Christmas tree. Actually, I think the Christmas tree is a lot smaller than that. Do you see that bright star in the middle, Kevin?
Yeah, this
I
guy.
always I always think that's the trunk of the tree, and then you've got stars, up and down or left and right if it was upright, and that's sort of the bottom of the tree, and then you can see the star that kind of the path of some stars going up where they meet where the cone nebula is, and that just looks like a even with the little stub at the bottom, looks like a Christmas tree.
Yeah, this
A lot of dust and dirt here too. There's gas and dust and everything. Somebody made a mess with this region in the sky.
yeah, I've never done a live stack on this one, and I thought it would be doing a little bit. The moon's also very close to this tonight, but here's a processed shot off of
Yeah,
the
there you
same
go.
telescope. So this
Hmm.
is what this telescope can actually do when we just leave it there for
Oh yeah,
hours. But that's what we're looking at. Except the orientation in the telescope here is this way, is how
yeah,
we're looking at it in the
yeah.
telescope right now. So the cone is over here,
You can see
and
those blue
then
stars in the shape of the Christmas tree. That really bright one being the kind of the stump there at the bottom. And
oh, there it is.
yeah, yeah,
Okay.
yeah. And then all of that blue is reflection nebula. So you've got dust and gas and just all kinds of things going on in this region. There's this little thing here is called the fox fur. In fact, I even swear I could see a little fox head with eyeballs bulging out on the side of it. It's probably my
You can
imagination, but
kind of see it hanging out there.
yeah, it's
Um,
very bright in HA. It usually turns out to be very nice and smooth and velvety in your long exposure photographs.
but
Yeah.
for short exposures, this was 5 minute pictures that were stacked on this.
Hmm.
So in a 5 minute image, you can see it. It's easy, but with 30 seconds,
Was
it
that
leaves a little
David's
bit
or
desired.
ours?
This is ours, the
No,
H alpha.
the color one. Was that
Oh,
David's?
it was a mix. I was shooting both
Oh,
telescopes.
okay.
So
Yeah.
hydrogen in one and color in another.
Yeah, you're not spoiled at all.
No,
Just
not at all.
shoot with two scopes at the same time and then mix the
Yeah.
data.
First rule of government spending. Why have one when you can have two at twice the price? So,
Indeed. Indeed. So yeah, I'm surprised this isn't brighter than this in HA2. It's actually
I
uh,
think the moon is
it's so
pretty
close to the
close to
moon.
it.
Yeah. It,
Uh,
the hydrogen alpha is usually really good against light pollution, and it's usually pretty good about moonlight. But if you're like right next to a really bright moon,
oh yeah,
that's a
we're
really
it
strong.
is
It's like right out of the frame or something, probably. But the
we're
moon is
about
really bright.
17 degrees from the moon right now, which
Oh, it's small. Yeah,
that's pretty close for what we're doing there. So,
yeah, yeah.
but anyway, that's that's the cone. We'll try that another time, hopefully, when the moon's not as close. And maybe we'll give that a go. But that was the first time we'd ever um, tried this one. I don't know why I keep getting multiple LTI stacks on this thing. So, but let me select the next one. This next one's going to be interesting because I think this is the one you were talking about where there's a lot of oxygen in it, Richard.
Oh, I think I do not have any proof. I don't have any quantitative proof, but I believe this is the brightest oxygen source in the sky. It's brighter. I know from experience, it's brighter in O3 than it is in hydrogen alpha.
The Sharpless 308 is in there too. With
Okay.
that, the dolphin with the.
But the dolphin's not as bright as this. The dolphin does have a lot of O3 in it, but it's not as bright as this. This just the O3 exposures on this image are just off the charts in comparison. So this target, I'll let Kevin. I don't want to steal Kevin's thunder, but it has a lot of oxygen. There's a lot of oxygen in this target, which makes it very bluish. You're going to see a lot of blue in color and narrowband images because it has a great deal. And actually, oxygen is more like cyan. It's kind of between blue and green. But you'll see a lot of that in photographs of this because of that source. It's also very strong in HA. It's a great narrowband object. It's fairly bright in both of those. But the O3, I'm just astounded by how bright it is in O3 compared to a lot of other objects. Many objects are really beautiful in O3, but you got to expose a long, long time. But this one here is just very plentiful. Have I mentioned that yet? It's really bright in O3. If I haven't gotten that point, okay.
Well, now I kind of pushed it because the O3 filter on this telescope lets very little amounts of light through. So we did a minute exposure. So hopefully it plays nice and just pops it up on the screen
what
here.
What are you talking about? There's nothing.
Did it again. I don't know why it keeps doing that.
So it takes a photo and then just switches back to the sky chart?
Yeah. Well, while that's doing that, this is Thor's helmet, NGC 2359. It's supposed to be coming up here. I know Ernie in the chat was asking about star clusters in the moon. We do have probably one or two more clusters in the lineup. We try to give a wide variety of what's up in the sky during these. Yeah, so we're looking about 12,000 light years away, 30 light years in diameter. And it gets its name because it looks like a Viking helmet. And hopefully when the image comes up here, you'll actually be able to see, the horns and, the helmet things.
And actually, this is something in a big Dob. It looks a lot like that. You can see those horns and the kind of that round skull cap between the whatever they are, the feathers or something coming off of them. I remember the first time I ever saw that visually at the Winter Star Party in a big Dob, and it was in my brain. It was like, what is that? And it suddenly rotated and clicked into place, and it was like, it looks just like Thor's helmet. It's a really nice, bright, large nebula. So this is our third.
It's actually a lot smaller than I think people think it is, though, especially on a big chip like what we're working with tonight. But it's really kind of an interesting nebula because while it is an emission nebula, there's a lot going on in it because it has this star in the center of it that's creating that helmet bubble, and those are called Wolf-Rayet stars. It's basically a star that's going through this evolutionary phase pre-supernova. It's a very big, extremely hot star, about 44,000 degrees Fahrenheit to 90,000 degrees Fahrenheit roughly is what these generally, hopefully the image comes up. There it is. So it's upside down, but there's the helmet and there's the horns, and hopefully the next, shot or so, it'll pop it up a little bit more and I'll zoom in.
I was going to say, I bet if you zoom in one or two and then just kind of drag the scale, it'll be noisy, but you'll be able to see it.
There we go.
There it is. Look at
Ernie, you probably could see this with
Also
an
upside
8-inch
down.
Dob and a O3 filter from a dark sky site. It's not as difficult as it. I think the problem, and I have the same problem every year, um, it's greatly overlooked because
Mhm.
you have Orion and the Horsehead and the Cone and the Rosette. All that big nebula stuff is not far from where this one is right now. So it gets overlooked, and I pass it up almost every year. By the time I realize, oh, I could have
Yeah.
looked at it, it's too low, and it doesn't get very high either, unless you're very far north. But because it's down in Canis Major,
Very far south.
so
Yeah.
yeah, it's
And
pretty.
if you have an oxygen 3 visual filter, by the way, the visual filters and the camera filters are not the same. But you can get an O3 filter that'll thread into the bottom of your eyepiece. This really pops again because it's really bright in O3. The only thing I could think of close to it is the Veil Nebula.
Mm-hmm.
Both of those are really bright in O3, and when you're looking at them visually, they look like ghosts. They just have this ghostly, ethereal, 3D look to them that images just don't capture the way that they look through the eyepiece. Um, so it's worth a look.
And it looks pretty similar, like how it's
Hmm.
sitting right now. Maybe not the faint dust you see down here, but it looks a lot like this in an average telescope in a dark sky with an O3 filter. That's actually how it looks.
Hmm.
Um, Obviously, bigger telescopes are going to have more reach. But you can see this bubble bow shock that's going off right there. This bright star right in the middle, that is the Wolf-Rayet star that is going through this pre-supernova, temper tantrum, if you will, and it's shedding off its outer layers into space before it detonates, and that's pushing all the material of the nebula out, making this bubble. And Wolf-Rayet stars are fairly rare. The only other one that I know really off the top of my head would be the Crescent Nebula, NGC 6888 in the summer, up in Cygnus. That's another Wolf-Rayet, but there are other ones out there, but they're pretty rare. But yeah, this is the I think it's WR7 is what that's called, but very cool thing to see, and really abundant region in oxygen. To be able to see that much detail in oxygen 3 in such a short amount of time, there's very few nebulas in the nighttime sky that can do that as well. So this is the Thor's helmet, NGC 2359, Canis Major, about 12,000 light years away and about 30,000 light years. Um, but
This is a
yeah,
very violent. This is very violent. There's a star. It's literally like a boiling cauldron, and it's
mm-hmm.
just blowing off hot oxygen and other materials in all directions. So it's making this bubble that's expanding, and you can see, one side of the bubble, at the bottom of this image, the top parts, there's too much dust and things going on, but it's this glowing bubble that's expanding from this star that's just blowing out stuff continually. It's pretty cool, but not
Yeah.
cool. It's hot.
It's cool, but not cool.
Cool.
So,
Hot.
but yeah, that's Thor's helmet. If you go to a dark sky site at the end of the month when the moon's out of the way, I definitely recommend trying to track it down, because it is very overlooked. I know someone mentioned it in the chat, but Trevor at Astro Backyard just did a video where he took his Esprit and his 694 camera and actually shot this and got a pretty nice run on it.
Hmm.
I always forget about it just because it's a cool nebula, but there's so many other things, and you have the Seagull Nebula not far from here too, which is really abundant for narrowband work as well. So it gets overshadowed quite a bit, but definitely worth checking out. So the next one is a lot easier, and it's a star cluster, and it's kind of an oddball for this time of year, but it is hanging way down there in the south part of the sky in Lepus, and that is M79, which is the 79th addition into the Messier catalog. So,
Not a
but
catalog,
it is,
not a comet number 79.
yeah. So wait for the telescope to get down there because it's kind of in a weird spot of the sky probably right now. So
And this probably did look like a comet. Through a small telescope, this is a fuzzy spot. You need, you really need about 6 inches or so, I think, to start resolving some of these globulars. Don't you think? Or maybe it's just
yeah,
how dark the
uh,
sky is.
there's a question: are we dithering? Does it dither when it's doing the live stack?
No,
No,
you get a natural dither because you're just taking short exposures. Then they drift from frame to frame, and the life stack actually aligns on the stars. So you get kind of a free dither, but it's not purposely moving the scope each time to do it. Um,
when we're normally imaging with the scope with the long
yeah,
exposures, it
we,
does
we'll
dither.
yeah we always dither for our longer stuff.
But yeah, those exposures are about 3 to 5 minutes each, so we'd be here forever looking at a black screen. But yeah, there's M79 right there. This was discovered actually by Messier's assistant, Pierre Machan, I think is his name,
Mm-hmm.
last name.
Close enough
Um,
on pronunciation.
yeah,
Yeah.
1780 is when he found this one. It's 42,500 light years away, about 6 light years wide. Um, what's interesting about this globular, it's one of two globular clusters. And if you don't know what a globular cluster is, if you were here earlier where we did the double cluster, that's an open cluster, a very expanded cluster of stars, where globulars are very dense balls of stars. Um, most globular clusters form a halo around the core of the Milky Way. Um, this one, however, is the complete opposite direction of that. It's about 60,000 light years from the galaxy's core, and it's only one of two in the Messier catalog that are this way. And it is believed to be originated from another galaxy. There's actually observations that have shown that there's kind of a dense um, amount of red giant stars in this region of Lepus and Canis Major, where they believe the Milky Way consumed a galaxy long ago. Because in this particular region, from what I understand from the observations there, that these stars are not common for this particular location. So that's one of the theories about why this globular cluster is kind of just floating out there in the ether, pretty far out from where most globulars are actually found. So it's kind of an oddball for this time of year, but it's one of the only globular clusters visible in the wintertime. But it's pretty far south. I've used it. I've actually looked at it in outreach events before, but it's small, it's dense, and it's low. Doesn't get very high, at least here from the Arizona, probably Florida skies as well. It gets a little higher in Florida, but
Yeah.
it's not the biggest cluster in the world. So
Fortunate. Globular clusters are also they're a real eyepiece treat. They just look like crushed diamond, and the I hate to use dynamic range because it's such a engineering nerdy turd, but the difference between brightness and darkness that your eye can detect is thousands of times greater than what your computer monitor can display. So when you look at some of these things through an eyepiece, there's a quality to it that no photograph can match, and globular clusters are a really good example of that. They're amazing, amazingly beautiful uh, visually through a telescope.
no, they're not. They're easy to image and easy
Mm-hmm.
to observe because they're not really affected too much by light, depending on which one it is. There's some globulars that are very difficult, but a lot of the
Yeah.
Messier globulars are easy to do from an average backyard,
Mm-hmm.
that they're not super affected by light pollution just
Yeah.
because they're stellar. They're not
Yeah.
some
It,
gaseous thing.
signal to noise wise, you don't have to expose for hours. A globular cluster is not a multi-night project either. Um, I've gotten some amazing shots just with 1 hour of data, um, or less on a
Yeah,
globular
you're just
cluster.
trying to pull some of the color out and kind of smooth the background out is all you're really trying to do. But they're so bright that the signal there doesn't take a lot to get that saturation of color to it. So.
Right.
But yeah, that's M79. I like making sure we get a variety of things there, and it's one of the only globulars. Globulars are normally something we do during the summer months where there's piles of them to go through, but in the wintertime, this is like the only one there. But it's kind of a cool one. It's hanging out down there in Lepus, so go out, check it out. It's a fun one to do from a backyard, and it's not difficult to do in a small instrument. Let me make sure I'm typing in the right thing. We're almost to the end of our little star party here. We've got a few more targets left to go through. I think we've got 3 more, including the one we're just about to slew to, and that's about it. But if you do like what you see here at the virtual star parties, please subscribe to the channel, leave a like on a video, and then we do this once a month. So come back. We'll be posting the link for March's star party, and we already are working on April's star party. April might be really interesting. We've got some really cool things in the works there. I don't have all the details to tell you guys about that yet, but stay tuned for the details on that. Hopefully by next month I'll be able to announce a little bit more on that, but yeah, stay tuned to that. So this is one of my favorite open clusters, and I'm not a fan of open clusters because I think they're kind of boring. But this one in particular, it's not even about the cluster. It's about what's kind of in the same field as the cluster. It's a 2-for-1 deal. But this is M46. It's another open cluster. And right next door is M47. I wouldn't be surprised if we actually clipped it into the field because they're very close to each other. So we might get a multitude of objects in here because M47 is right next door. No, we kind of lucked out.
Well, I see it though.
Yeah. This is M46 and its little companion NGC 2438, which is this little tiny planetary right here. It's one of my favorite ones. I meant to do it last month and totally skipped over it. It's another one of those where there's so many big, easy targets that people want to see this time of year that it's really difficult to see it. Or not difficult to see it. It's really difficult to remember some of these objects that sit way down in Puppis and Canis Major and stuff like that. And all that fun stuff. But Richard, Sal Grasso says hi.
Oh, hi, Sal.
Long time no see.
He bought my He bought my observatory actually. Yeah.
And now you have this one. So.
Yeah. There's actually, I don't know that we're going to pick it up. There's a little tiny second planetary in this field.
Oh yeah, some of these clusters actually have actual other planetaries in them.
We might have to go a little deeper to pull it out, but in the first image, I could see the one that you like. Just pop right there.
Yeah, looks like a little bubble in its field. Let me see if I can figure out where it sits. Oh, it's not in the cluster though. It's actually hanging out.
It's out a little bit.
It's in the field.
But, yeah, I don't think we can find it. I probably shouldn't have mentioned it, but I just remember. I remember when I shot this with the Quattro, and it was like, what? There's another little thing here. It surprised me. I didn't know it was there.
Should be right over here.
Yeah, but that one there, that one is really easy to capture. Just almost any exposure, you'll see that little smoke ring. There it is. All right, very impressive, Kevin. I would never have found that.
Yep. So there's
there it is.
Double planetaries. That's actually pretty impressive for luminance.
Mm-hmm.
But there's 2 planetaries. So this is M46 right here. This is NGC 2438, and then this little tiny thing right over here is another one. That's Minkowski 1-18 is the name of that one. It's actually really abundant in hydrogen. I shot this like a year ago. There's also plenty of other weird catalog numbers. It's very faint, very small, about 14th magnitude for that planetary, which means you're about pushing the limits of a 16-inch telescope to see it. But it's very small at this point and difficult to catch. But yeah, that's the second planetary in the region. But I forgot about that one. I even have a processed shot about this one too. I know Richard's got some notes on this real quick if he wants to elaborate while I try to dig out the actual documented thing here. That's not it.
Richard has notes on this?
I thought I had notes for you. I completely
that Word
forgot
document. Yeah. No, I haven't been referring to that. I've just been goofing off.
It's not important. I thought I had a charted one for this. Yeah, whatever.
It's only 1.5 degrees from M47. I am surprised we didn't pick up M47.
Yeah, if we offset it, it would have worked. But
yeah, it is 5,400 light years away, and it's 29 light years across, so it's big.
I think what's really cool about this particular one is the planetary is actually a foreground object. It's not a background object. So it's 2,900 light years from Earth. So it's about half the distance between Earth and the cluster. So it really has nothing to do with it. Now, this other little guy back here, I couldn't tell you. It's just there it's like a background galaxy.
It's probably really far out.
But yeah, so that's the two right there. I wonder, planetary nebulas are usually very abundant in oxygen-3. I wonder if we flipped, or at least hydrogen.
Yeah,
this one's really pink, actually. I'm going to just put the hydrogen filter in real quick before we jump off the deep end into the realm of galaxies.
We're going to detect hydrogen.
Yes.
Dun, dun, dun.
So we're going to go from visual light to hydrogen and see if the filter helps kind of pop those planetary nebulas out. This guy right here should be very easy. This one should come out, but it might be kind of faint. I mean, it's already faint, but we'll see if it pops out a little bit more from the background of those stars there. But it's very ghosty looking little thing in there. But let's see it do the change out here. See how it looks. Kind of. You can kind of see how it eliminated that, but you stretched it a little bit.
Oh, there it is.
And you can see it. It kind of knocks that out.
And I'm looking at it through internet compression.
Yeah.
But I see it.
Yeah. But yeah, 2 planetaries in one. Well, in one field. They don't really have anything to do with each other, but the fact that you can actually see that, that was a good catch. Completely forgot about that one on that. But yeah, so that's M46, NGC, I can never remember it off the top of my head, NGC 2438, and Minovsky 1-18, this little guy right here. And those are the planetaries in the region, along with the M46 open star cluster. So I'm going to go ahead and stop that because we've got galaxies to get to. We've got 2 more targets to do, and then we're going to wrap it up for the evening. So thanks for hanging out with us tonight. It's been, hopefully you've had a good time roaming the night sky. Now, we're getting to that part of the year where, we're pretty deep in winter now. There's only about a month left of winter officially in the Northern Hemisphere. And then we get into spring. And a lot of those big, bright objects that we like shooting, like the nebulas and stuff, get lower and lower before we make the transition to where we're no longer looking along the galactic plane. In the wintertime, we're looking along the galactic plane out away from the core, and then the summer we're turned to where we're looking down into the core. And then during spring, we're looking away from the plane out into intergalactic space, and it's galaxy season at that point. So if galaxies are your thing, over the next couple months, for the virtual star parties, it's going to be galaxies galore. And one of the easiest and ones to get right now, of course, is M81 and M82, the two companions that are hanging out up in Ursa Major, about 12 million light years away. And everyone shoots this one as well, but this field is very complex. There's a lot of galaxies, but there's also some nebulosity in there as well. The Flux Nebula, which you've probably seen as well, Richard.
Flux Nebula. It sounds so sci-fi. The Flux
Whoa.
Nebula. So the Flux Nebula, by the way, we're not just making this up. It's very, very faint material that you see out between when you get a field that's just a bunch of galaxies. There's not a lot of stars. There's a lot of this just stuff floating around out there that glows from starlight and galaxies. And in a long exposure with a sensitive camera, you can see it. And it's funny, I use Flux Nebula as an example of how astrophotography is evolving, because 10 years ago, to capture the Flux Nebula was like, yeah, I got the Flux Nebula. You exposed a long time. I exposed for 3 nights in a row with a 50-inch telescope, and did all this stuff. And now Kevin just gets Flux Nebula by accident, just all the time. He's like, oh, I shot this globular cluster, and oh, it's got all this Flux Nebula around it. And that's because that's very faint, and the noise on cameras, on these newer CMOS cameras, is so low that these very faint signal that we used to have to work really, really hard to pull out is just showing up all over the place with very minimal effort. But I remember the first time I captured the Flux Nebula in this field, I thought, what is all of this stuff? I need to correct it. And it's like my flats are bad or something, because there's all this swirly stuff around these galaxies. I don't think we're going to see any Flux Nebula here with these short exposures.
I'm going to find an image of it
all right,
while we're talking here.
Find one, but yeah, and I swear 9 out of 10 images have M81 and M82 both in them, because there's such a nice little pair. And most amateur setups are wide field enough that it'll get both galaxies at the same time. The one that you see on the right, I'll just kind of make up stuff while Kevin's looking for a Flux Nebula image. The one on the right, often called the Cigar Galaxy, and in long exposures with that, you can. Did I say left? I meant right. Yes, the little one that looks like a cigar. That's the one that's the Cigar Galaxy. It has these little fingers in the center that shoot out in both directions, that are hydrogen. They're really bright red in hydrogen, so they show up with a hydrogen alpha filter very readily. But also a lot of color images will show those. It looks like lightning or something shooting out of the core. It's really really cool. But again, 20 years ago, nobody was getting that, in amateur images, and now people are getting that, all the time. It just keeps marching forward. Bode's Nebula, the one on the left, and actually I mean left this time. Yes, left. That's a beautiful spiral galaxy, and you do see people with longer focal lengths. They'll just capture that galaxy by itself sometimes, because it's got some structure in it. It's quite. Oh, there we go. Yeah.
This is the luminance channel.
So. Yeah. Look at all that crap in the background. What is that? That's just noise, or I got frost on my sensor, or your camera's crappy. I want my money back. No, that's there. That's there. And the reason we know it's there is because it has a pattern to it. It's not random. And lots of people with lots of cameras and lots of different telescopes, they all get the same general pattern. So it's real. It's really there, and that's just simply the intergalactic stuff. It's not really intergalactic, I don't think, but it's that stuff between the stars that in a long exposure, they do reflect light, and if you have a sensitive enough camera, and you can see a little bit, Kevin. Highlight the little lightning rods coming
I was
out.
pulling up the color shot
Oh,
for
okay.
the
Okay.
hydrogen.
Yeah, yeah, you can see that in this image. Now this one is stretched a little aggressively, but that a lot of that structure you see there is very it's real. It's real stuff.
Yeah. So all this was taken off of the telescope we're actually working on right
Mm.
now. So just hours and hours and hours and hours of work on it. But yeah, that's them right there. M81, M82. These are easy to see. You can get these in a pair of binoculars from your backyard for the
Mm-hmm.
most point. And you can actually see them. One and two. They're all
Yeah, yeah.
generally in the field. Very easy to see. Even in like your little finder scope, you can see it. But you're looking 12 million light years away. And in a dark sky sight, it's awesome because if you get M81 in the view, it looks like a big UFO in there because it's got these big spiral
Yeah.
arms and all kinds. It's very dramatic. Um, but that's because it's nearly 70,000 light years across, where M82, the Cigar Nebula, is 37,000 light
Yeah.
years across. So, and they're only about 150,000 light years apart from one another. So they're very close. And at one point, they did interact with each other. And that's why a lot of that red, lightning stuff that Richard was talking about
Got drawn out by the gravity.
is, yeah, all that got messed up when
Yeah.
it came out there. So, but that's actually expanding outward about 600 miles per second. Those little tendrils coming out of the
They're booking.
core there. So
Yeah. This is easy to find in a telescope because they're these shapes are very distinctive and it's like really obvious. There's a little slit and then there's this little disc um, in the field of view. Yeah.
they're very easy. And there's a bunch of other galaxies in there too. As you start to get into darker locations, you'll notice all these little fuzzies start to come out in the background. So,
Yeah.
but
It's
that's these are rising right now in the east with Ursa Major, the Big Dipper. They kind of lead the Big Dipper up as it comes up. So these are kind of the first major companions of galaxy season is coming, followed by the Whirlpool and a bunch of other ones that are coming up as it gets later and later into the night, into the early morning. But springtime is right around the corner when you start to see these coming into the sky. So that's M81 and M82, 12 million light years away. Originally discovered in 1780. Wait, I'm sorry. I jumped ahead on that. 1779. 1774 is when Johann Bode found this one and called it Bode's Nebula. It's not a nebula, it's a galaxy.
It's not really. You're right. We didn't know the difference at that
Yeah,
time. Yeah,
they were
didn't know
fuzzies.
we didn't know the difference.
But in 1779 is when they added it to the Messier catalog, thanks to Pierre Machan adding that to the catalog as 81 and 82 for the Messier catalog. So getting pretty late into the Messier catalog. It is part of a lot bigger group of the M81 group of galaxies, where there's 34 galaxies in the group overall. And these are actually the nearest grouping of galaxies to our own local group, where our Milky Way, Andromeda, and M31, M33, the Triangulum galaxy, kind of hang out. So these are our neighbors when it comes to intergalactic clusters. All right, last target on the list. For those of you who've been hanging out with us for the last 2 hours, thanks very much. Please keep an eye on next month's webcast. We'll have my buddy Gil Esquierdo on. Gil is a professional astronomer with Mount Hopkins. He runs the 60-inch telescope. He does exoplanet research. Oh no, it crashed on me. How dare you?
You're gonna have to speak to the programmers.
I know. I don't have an in as much now. This is the beauty about remote imaging. Every now and again, it just riots against you. So, you just make it work. So,
Right. Even for remote, when somebody goes, "Wow, you must have a nice telescope," you just want to shoot them because, like, you have any idea how hard it is to get all this stuff to work together?
yeah.
And keep working together. Did you start 2 copies?
Uh, nope.
Okay. Okay.
Select target. Okay. So this is the last run, last target for this one. But yeah, big thanks to Richard for hanging out with us from Florida tonight. I know it's getting late on the East Coast. I'm sure some of you are watching from the East Coast or wherever you are. Always nice to see everyone hanging out with us. So hopefully you've had a fun time tonight and enjoyed what you saw. And we appreciate you hanging out and exploring the night sky with us from wherever in the world you are. But it's been pretty fun hanging out. So last target of the night, this is the Leo Trio, a very popular set of galaxies. I think it's probably one of Richard's favorites.
I have a lot of favorites. I do. Yeah. Yeah, this is a really pretty field. Again, if you don't have a long focal length to shoot a galaxy, there's a lot of interesting clusters and groupings of galaxies. From Arcturian's chain, where you just have this big splat of galaxies all over the place. And this is one, because all three of these galaxies, in their own right, they're beautiful. One of them is called the Hamburger. That's probably one of my favorites, is the Hamburger galaxy. But they're all three, by themselves, they're beautiful little, and they're colorful. Sometimes galaxies, once the galaxies start getting very small, it's tricky to get a lot of color and things. Oh, you got some glare from the moon or some clouds going through.
I think it's also pretty low, but there's the Leo Trio through some kind of haze.
Yeah. The one on the upper right is the Hamburger galaxy, what I call I've heard other people call it that too. That's one of my favorites. Just a funny looking galaxy, but cool.
Yeah, there's some high haze.
There's some haze.
You can see it moving. So
can't beat the weather.
No, it's how that works. You always got to fight with it somehow. But so this is the Leo Trio. It's actually kind of low down there as well. So the bottom one down here, this is M65, Messier 65, M65, M66. These two right here were discovered by Charles Messier in 1780, and then NGC 3628, which is the Hamburger galaxy. That one wasn't discovered until 1784 by William Herschel, 4 years after these. And it is quite a bit fainter.
How did he miss it?
Okay. It's a bit fainter.
It's right there. It's right there.
But, yeah, no, it's...
All right.
Yeah, that's what it is. So. M66 is actually the largest galaxy out of the trio, 190,000 light years across. I don't know why this one should be bigger, but that's how it is. But these two galaxies, M66 and M65, have actually kind of played around with 3628 over here. This has a massive tidal stream of stars that goes way out there, about 300,000 light years long, of this tidal tail. Very, very faint. We'll have to try and pull that out in an image this spring as these get higher into the sky. But very cool detail there. These are great in small telescopes. They're fun because you can get all three in one field of view normally, so it's a really fun set of galaxies to show people or just yourself. They can be a bit challenging from the backyard. You could probably pull out M66 and 65, but the Hamburger is going to take a bit more effort, even in modest telescopes from a light polluted location. But in a dark sky, even small telescopes can get all three without much effort. So, which means I don't know why he didn't get the third one there.
I've seen them visually, but it was with a 14-inch Dob. So
yeah.
Okay, I guess.
He tried, so he got 110 objects.
We'll give him a waiver on that one.
There you go. Well, guys, thanks for hanging out with us. That is another episode of Star Stream by Focus Astronomy. Join us next month in March. We'll get the link up probably in the next week or so for the next episode. April, we have a really cool episode in the works. Some really special stuff, some really big telescopes. Hopefully, if all that comes together, hopefully have more details on that. Big thanks to Richard for hanging out with us late into the night.
It's fun.
And yeah, no, it was, thanks for being here. And then big thanks to Skies Away for hosting the telescope. If you want to know more about Skies Away, Google Skies Away observatories. If you want to install your equipment out there, talk to Brian. He'll be able to take care of you on that. And yeah, other than that, please have a safe weekend, clear skies, and we will see you guys next month. Take care, everyone, and have a good one. Bye.
Bye-bye.